So here we go, integration with trigonometry. Remember, integration and differentiation are inverse operations to each other. So what does that mean for us? That means that the antiderivative of cosine x dx is equal to sine of x plus c. And you might say, well, what would possess you to say that? And I would say, well, remember that the derivative of sine with respect to x is equal to cosine. So we're going this direction with antidifferentiation. So I'd like you to pause right now and see if you can't fill in these other two antiderivatives. What's the antiderivative of sine x? And what's the antiderivative of secant squared x with respect to x? So for the second one, the antiderivative of sine x dx, we're asking what function has a derivative equal to sine x? And you might say cosine x, and you'd be close, but it's negative cosine x. C, of course, constant of integration. And what function has a derivative of secant squared x? That would be our good friend tangent x plus c. These are all available to you by knowing the derivatives for sine, cosine, and tangent. So let's go on to our next cosine 5x dx. There's shortcuts for doing this. If you can do this in your head, great. I'm a big fan of using a u substitution. So u equals 5x. This is for a function composition, you'll remember. Du is equal to 5 dx. So in order to get 5 dx, I need to multiply by 5 in here. Now I've got 5 times dx. But to balance it out, we multiply by 1/5. So what I'm sort of looking at here instead is 1/5 times the integral of cosine u du. And what's the antiderivative of cosine? Well, it's sine. So we have 1/5 times sine of u, but u is 5x plus c. And there is this indefinite integral worked out. So now, a little bit more complicated. 2 sine x times of 5 minus 3x dx. What do we do? Well, we're going to start off with another u substitution. Let u equal the inside part of the sine function, 5 minus 3x. Du equals negative 3 dx. So I have 2 dx right now. I've got a 2 here times dx, but I want a 3 dx. So I'm going to multiply by 3, and actually I'll need to multiply by negative 3. And to balance it out, we also multiply by negative 1/3. So this whole piece becomes du. We've got negative 2/3 times the integral of sine u du. What's the antiderivative of sine? The antiderivative of sine is negative cosine. So you have negative 2/3 times negative cosine of u, but u was, remember, 5 minus 3x plus c. And we can clean this up just a little bit. My screen's getting away from me here. We have 2/3 cosine 5 minus 3x plus c. Just a whole variety of examples for you today. Going example crazy here. Why don't you pause the video and see what you can come up with for this. I keep saying u as a hint. So let's let u equal x over 4. Du is equal to 1/4. Now, here's a little wrinkle. I've got this 1/2 here already. I need to see times 1/4. So I'm going to multiply by 1/2, because 1/2 times 1/2 is 1/4. And to balance out, we would not multiply by 4, but we would multiply by 2. So this piece, that piece multiplied together gives me du. And then we have 2 times the integral secant squared of u. Antiderivative of secant squared is tangent 2 tangent of the u, which is x over 4, plus c. There we go, there we go. On to the next. Okay, so this one's a little bit different. There's not really something inside of another function. This is not, ladies and gentlemen, I repeat, not one we're going to use a u substitution right off the bat. Sometimes it's very important to remember our trigonometric identities. And we happen to have a trigonometric identity for all of that stuff. We know that all of that stuff is sine 2x. That's one of our double angle identities. So this is really equivalent to the integral sine 2x dx. And now it's just like one of the early examples that we had. I'm going to throw a little u substitution in here. So we need a times 2, we need a times 1/2 to balance. We have 1/2 integral sine u du. And what's the antiderivative of sine? It is cosine, opposite cosine. So we have negative 1/2 cosine of u, which is 2x. And of course, not forgetting our constant of integration. And there we go. Looking at the next example. Oh, they seem to be getting bigger and bigger and bigger. This is another one where a u substitution comes in very handy. We know that 2 cosine squared of theta minus 1 is a double angle identity for cosine. Yes? So what can we rewrite this as? We can rewrite it as cosine 2. But what's the theta here? The theta is this 3x. So what we really have is cosine of 6x dx. And now we're off to the races. This is something that we can do a u substitution for, or we can recognize that when it's just a constant times x in there, we have 1/6 times that interval 1 over the constant. And the antiderivative of cosine is sine plus c. And there we go. One more example down. Tangent squared x over 3 plus 1. Wow. These just seem to be getting crazier and crazier, but hey, we can handle it. We're all right. This is another identity. The identity that we have here is tangent squared plus 1, and tangent squared plus 1 is the same as secant squared. And hey, we know the antiderivative of secant squared. It's tangent. So our constant here in the parentheses, if we do a u substitution, we would need to have 1/3 dx, and to balance it out, we'd have 3 times that. So we have 3 times tangent x over 3 plus c. As you're comfortable with these simple integrations, you might not need to actually write the u substitution down. If you continue need to do so, I wholeheartedly encourage you to continue that practice and show that little step along the way. This problem, and then I'll stop this video, we'll look at the rest in the next video. But let's take this antiderivative. It puts a lot of the pieces together. I would really like it if you would pause this video and see if you can't find the antiderivative of this big, long, fun, glorious thing. All right, so we have 4 terms. We're going to integrate each one of them separately. Nice thing about e to the x is its antiderivative is e to the x. So the first term, 7e to the x. What's the antiderivative of negative 3x squared? Well, it's negative x cubed. Antiderivative of 1 would be 1x. And then minus the integral of 2 sine 2x dx. I'll write this one out. It's a little bit bigger of an antiderivative. I'm going to take it a little bit slow. Again, if we do a u substitution, we know that we need a 2 dx to get our du, and the antiderivative of sine is cosine. So I have my 2 dx to get my du. I'm going to have minus negative cosine 2x minus a negative just becomes big old positive. We've got plus c, and the rest of this goodness right there. So this whole thing is the antiderivative of that original problem. So let's pause here. Let's come back to this in the next video.